Arras, France. 21 May, 1940. Dawn light filtered through smoke drifting across fields south of the town. In German forward positions, anti-tank gun crews of the 7th Panzer Division prepared for what intelligence reports promised would be a routine engagement against British cruiser tanks. The standard 3.7 cm PaK-36 had stopped every Allied tank encountered in the campaign. Standing orders were clear: armor-piercing rounds, 500 meters, center mass. By mid-morning, those orders meant nothing. Direct hits produced sparks and ricochets, but no penetrations. Frantic radio traffic reported British heavy tanks, immune to all weapons. General Major Erwin Rommel redirected 8.8 cm anti-aircraft guns into direct fire positions. Only then did the British advance falter. What the Germans encountered was not expected. It was a design born from committee tables in London 4 years earlier, a vehicle that would rewrite anti-tank doctrine across 2 continents. This is the story of Matilda II. On committee tables lay typed memoranda defining 2 distinct British tank classes: cruiser for speed and exploitation, infantry for protected advance with foot formations. Minutes summarized the requirement in precise language. The infantry tank must resist all known anti-tank weapons. Maximum protection. Modest speed acceptable. Interwar European tank designs balance speed and protection in single chassis. France built the Saumur S-35 with 47 mm armor and 47 km/h top speed. Germany's Panzer III combined 30 mm protection with 40 km/h mobility. Britain chose differently. The decision was deliberate. Split the roles. Sacrifice speed for armor in the infantry tank. Accept the trade-off. War Office Directorate of Mechanization coordinated with industry. Vickers Armstrong received the initial contract. Fowler and Ruston and Hornsby joined production planning. The design carried the military designation A-12. The production name became Infantry Tank Mark II. Crews would call it Matilda. The specifications were extraordinary for 1936. Cast and rolled plate armor up to 78 mm thick. For context, most contemporary tanks carried 20 to 30 mm. The main armament, QF 2-pounder, a 40 mm high-velocity gun with excellent armor-piercing performance. Power plant, AEC 174 horsepower diesel, twin engines driving through a Wilson epicyclic gearbox. Combat weight is approximately 27 metric tons. Road speed 15 km/h. Maximum. Production man-hours were roughly triple those required for a contemporary cruiser tank. Each hull required extensive casting work, machining, and fitting. The turret alone took weeks. The armor was the thickest fitted to any production tank in 1939. War Office Committee minutes from 1936 and General Staff policy papers on mechanization documented the thinking. Pre-war trials files indicated the design goal: invulnerability to the 3.7 cm class of weapons. That caliber defined the standard anti-tank gun in European armies. German PaK-36, Dutch Baller, Polish Bofors variants. All fired shells that could penetrate 30 to 35 mm of vertical plate at 500 meters. Matilda's frontal armor was 78 mm. More than double the threat standard. The design decision would trade operational tempo for survivability. In 1940, that trade would alter enemy weapon schedules across Europe and North Africa. In September 1939, Britain entered the war. The regular army fielded only a handful of Matilda IIs. But the armor standard they embodied was years ahead of the guns designed to stop them. Movement orders placed 1st Army Tank Brigade in support of BEF infantry divisions along the Franco-Belgian border. Brigade composition included 4th and 7th Royal Tank Regiments. Park inventories listed many Matilda I tanks, the earlier A-11 design armed only with machine guns, and far fewer Matilda II gun tanks. The A-12 was still ramping up production in Britain. German Abwehr intelligence assessments in late 1939 judged British armor limited and lightly armed. Technical evaluations suggested cruiser tanks comparable to German Panzer II and early Panzer III variants. No mention of heavy infantry tanks. In reality, The A-12's 78mm armor presented an unanticipated threshold that intelligence had not detected. Brigade command fell to Brigadier H.E. Bowman. Under him, 4th RTR and 7th RTR prepared for the methodical warfare British doctrine anticipated. Infantry tanks would advance with foot soldiers, breaching fortified lines, suppressing machine gun nests. The 2-pounder gun provided direct fire against bunkers and light armor. By May 1940, approximately 58 Matilda IIs were available in France. That number represented the entire deployed strength of Britain's most heavily armored operational tank. Each one had been shipped across the Channel with spare parts, ammunition, and crews trained on the peculiarities of twin diesel engines and Wilson gearboxes. On the German side, divisional anti-tank companies and regiments commonly fielded the 3.7cm Pak 36. Firing tables showed typical penetration around 35 mm at 500 meters with standard armor-piercing projectiles. The gun had been effective against Polish 70p light tanks and French R-35 machines. Doctrine assumed it would suffice against British armor. BEF equipment returns from spring 1940 documented the balance. British tankers expected to provide close support to infantry. German anti-tank gunners expected to defeat enemy armor with standard doctrine. Both sides entered the campaign with firm expectations. Tables of organization and equipment for German anti-tank units showed no weapons heavier than 5 centimeters in the divisional anti-tank role. The 8.8cm Flak 18 was an anti-aircraft gun, positioned with Luftwaffe flak battalions for air defense. Technical firing tables existed for ground targets, but employment doctrine prioritized aircraft. The first large-scale contact between Matilda II and German anti-tank defenses would show that one of these sets of assumptions failed within minutes. That contact came at Arras. 21 May, 1940. Orders for a counterattack assigned 4th RTR and 7th RTR to strike German spearheads near Arras. Objective: delay encirclement of the BEF and French First Army. Crews loaded 2-pounder armor-piercing rounds. Infantry prepared to follow the armor. German 7th Panzer Division under General Major Erwin Rommel expected light and cruiser tanks vulnerable to 3.7cm guns. Initial contact reports were routine. Then the firing began. Pak 36 crews followed training. Range 500 meters. Center mass. Fire. Direct hits. Sparks. Ricochets. No penetrations. Closer range. 300 meters. Fire. Same result. The shells bounced off. Unit logs recorded the phrase that would appear in multiple after-action reports. No effect. The attack strength included approximately 74 British tanks. The majority were Matilda types. Around 58 were A-12 Matilda IIs with the heavy armor. German gunners fired repeatedly. Standard armor-piercing rounds at ranges where they should have been effective simply failed to penetrate the frontal glacis and turret. Rommel directed 8.8cm Flak 18 anti-aircraft guns into direct-fire positions. The 88mm guns had been designed to shoot down aircraft at high altitude. Their muzzle velocity and projectile weight gave them penetration far beyond the 3.7cm guns. Flak crews lowered their barrels to horizontal. Direct fire. Ground targets. Only then did penetrations occur. Only then did the British advance falter. British losses at Arras included approximately 23 Matilda IIs. After-action analysis and German reports made clear that the overwhelming majority were knocked out by 88mm guns and field artillery, not by standard anti-tank weapons. The 3.7cm Pak 36 had proven inadequate against the A-12's armor at combat ranges. British Expeditionary Force after-action reports and Army tank brigade summaries documented both the temporary success and the ultimate containment. But the operational significance went beyond the immediate tactical outcome. Arras forced an immediate German workaround. Employment of the 8.8cm Flak in the anti-tank role became standard procedure. More importantly, it triggered higher-level weapon reevaluation. German commanders filed reports. Technical branches analyzed armor samples. Procurement offices received urgent queries. Within weeks, Orders in Berlin shifted to accelerate development and production of guns that did not yet exist in sufficient numbers at the front. The Matilda II had done what its designers intended. It had resisted all known anti-tank weapons. In doing so, it had forced the enemy to redesign his arsenal. A technical synopsis from OKH collated field reports from the Arras engagement. Subject line: British new heavy tank immune to 3.7 cm. Countermeasures required. Staff officers annotated penetration curves against various armor thicknesses. They examined firing angles and projectile performance data. Pre-campaign planning had assumed the PaK-36 would suffice through 1941. Arras evidence invalidated that forecast. The assumption had been reasonable based on known Allied tanks in 1939. But the Matilda II had not appeared in significant numbers until May 1940. Intelligence had failed to detect its deployment strength or capability. Heereswaffenamt directors convened meetings with procurement branches. Rheinmetallborsig engineers briefed on the 5 cm PaK-38, a 50 mm L-60 gun already in development. Acceleration orders moved delivery timelines forward. Initial production units were scheduled for late 1940. Trials with the PaK-38 confirmed improved performance over the 3.7 cm gun. The 50 mm armor-piercing round offered better penetration at range. But tests also showed limitations. Frontal shots against a face-hardened plate of 78 mm remained problematic at typical combat ranges. The PaK-38 improved the odds, but it did not guarantee a kill. Discussions turned to heavier weapons. The 8.8 cm Flak 18 had proven effective, but it was a large, heavy gun optimized for anti-aircraft work. Tactical mobility in the anti-tank role was limited. What the Army needed was a dedicated anti-tank gun with performance exceeding the 50 mm class. By late 1940, the 7.5 cm PaK-40 entered fast-track conceptual and development stages. The PaK-40, 75 mm L-46, would eventually become Germany's standard heavy anti-tank gun. Its development was directly accelerated by the Matilda problem. Procurement directives and correspondence from summer 1940 documented the urgency. Firing trials compared PaK-36 projectiles against face-hardened plate representative of British practice. The results were filed with recommendations. The Heereswaffenamt issued revised tables of fire and doctrinal notes. Instructions now emphasized combined use of 88 mm flak, field artillery, and maneuver to defeat heavy armor. Germany's fastest army, the force that had covered hundreds of kilometers in weeks, paused to retool. Not its tanks first, its guns. A single tactical shock at Arras translated into a strategic rearmament curve. New anti-tank guns. Revised doctrine. Allocation of 88 mm flak assets to forward anti-tank roles. The ripple effects would extend across theaters. And the Matilda II was about to deploy to a new theater where Italian guns were even less capable than the German 3.7 cm PaK. Matilda was going to the desert. Crated hulls and spare bogies arrived at Egyptian ports aboard transport ships. Workshops at railheads and forward depots began refitting. Desert filters installed on engine intakes to prevent sand ingress. Cooling systems adjusted for higher ambient temperatures. Sand shields fitted to tracks and suspension. Each tank required theater-specific modifications before operational release. The A-12 had been conceived for European lanes and hedgerows. In the open desert, its characteristics took on different significance. The heavy armor remained advantageous, perhaps even more so in terrain with long sight lines. The diesel engines proved more reliable in heat than gasoline engines, with lower fire risk. But the slow speed became more pronounced when covering large distances between water points and supply depots. Italian fortifications and anti-tank guns in Libya were not optimized to defeat 78 mm plate. Italian forces relied heavily on the Cannoni di 47 Trentadue, a 47 mm gun of adequate performance against light and medium armor. Penetration data showed the 47 mm round could defeat approximately 40 mm of vertical plate at ranges beyond 200 meters under good conditions. Against Matilda frontal armor, that performance was insufficient. British test notes from theater workshops documented near-immune results at common engagement ranges. Crews reported confidence in frontal protection during training exercises. The Matilda's 2-pounder gun outranged Italian tank armament and could penetrate any Italian armored vehicle in service. By November 1940, Middle East Command listed roughly 120 Matilda IIs available for Operation Compass. Supporting units included 7th RTR and 4th RTR, now rebuilt after France. Western Desert Force under Lieutenant General Richard O'Connor prepared for limited offensive operations against Italian 10th Army positions in Egypt. Italian intelligence assessments of British armor strength were incomplete. Reports noted the presence of cruiser tanks and light tanks. The Matilda II's deployment in significant numbers came as a surprise to forward Italian units when combat began. The transfer of a European infantry tank into a desert environment created a temporary qualitative dominance. British planners understood this. The Matilda's combination of protection and firepower, operating against Italian 47mm guns and medium tanks, produced a mismatch favoring the British. Combined with superior logistics and aggressive maneuver doctrine, the Western Desert Force held a tactical edge. Operational orders emphasized encirclement and exploitation. Matildas would breach fixed positions. Cruiser tanks and motorized infantry would exploit breakthroughs. The plan called for limited objectives: disruption of Italian positions and capture of forward supply depots. The actual results would exceed the plan. In a campaign of encirclements and pursuits, the slowest British tank became the fastest way to collapse fixed positions. Fortified camps with anti-tank ditches and barbed wire fell in hours, not days. Defenders equipped with weapons designed for the previous war found themselves unable to stop the advance. The Matilda was about to achieve its most successful campaign. Orders of the day specified limited objectives: raid Italian positions at Sidi Barani and Nabewa. Withdraw before Italian reserves could counterattack. The results exceeded the plan within the first 48 hours. At Nabewa, 9 December 1940, Matildas breached the camp perimeter at dawn. Italian defenders expected to stop tanks with anti-tank guns and obstacles. The 47mm guns opened fire. Rounds struck Matilda hulls. No penetrations. The tanks continued forward. Defenders abandoned positions as British infantry followed the armor into the camp. Western Desert Force captured thousands. The raid became an advance. Bardia fell. Tobruk fell. At each fortified position, the pattern repeated. Italian anti-tank guns engaged at prescribed ranges. Matildas absorbed hits and continued. Camps designed to withstand siege collapsed in hours. Data from multiple actions confirmed Matilda frontal immunity to Italian 47mm guns at combat ranges. Side shots at close range could penetrate, but frontal engagement produced ricochets and surface damage without killing the vehicle. British records list approximately 38,000 prisoners captured at the Nabewa and Bardia engagements. By the operation's end in February 1941, aggregate prisoner counts exceeded 130,000. Material losses included hundreds of Italian guns, vehicles, and tanks. British losses in the early phase included roughly 10 Matildas, combining combat losses and mechanical breakdowns. The loss rate was extraordinarily low for an offensive operation of that scale. On 6 through 7 February 1941, at Beta Fam south of Benghazi, a British blocking force of fewer than 40 Matildas and supporting units intercepted an Italian retreat column. The column included approximately 120 tanks and heavy transport. Italian forces attempted to break through. British tanks engaged at close range. 2-pounder guns fired armor-piercing rounds. Italian M1340 medium tanks carried 30mm frontal armor. British rounds penetrated consistently. Italian return fire failed to penetrate Matilda armor. The engagement lasted 2 days. When it ended, the Italian 10th Army had ceased to exist as a fighting force. Western Desert Force counted vehicles, guns, and prisoners across miles of road. The victory that began with a small raid reset the balance of North Africa for months. Technical debriefs noted that Italian anti-tank doctrine had not anticipated armor of Matilda thickness. The 47mm gun had been adequate against the lighter tanks of the interwar period. Against 78mm it was obsolete. Italian Commando Supremo Comuniques acknowledged anti-tank shortfalls in after-action reviews. Armor superiority at the point of contact produced cascading encirclements and loss of Italian material. The Matilda had fulfilled its design brief: provide protected advance for breakthrough operations. In the desert, where maneuver space allowed encirclement, that breakthrough capability translated into operational collapse for the defender. But the operational situation was about to change. Berlin had monitored the disaster in Libya. Reinforcements were already boarding transport ships. The force arriving in Tripoli would bring new tanks, new guns, and a commander whose name would dominate the North African theater for the next 2 years. The Deutsches Afrika Korps was entering the field. And this time, the Germans brought 88mm guns from the start. Disembarkation of Deutsches Afrika Korps units introduced Panzer III Ausführung E through G variants and Pak 38 50mm guns into the theater. Reconnaissance elements made contact with British screening forces in late February. Initial firing results in the desert reported marginal or no frontal penetrations on A-12 Matildas at 500 meters. Again, German anti-tank crews filed reports similar to those from Arras. The 50mm gun improved odds compared to the 3.7cm, but reliable frontal kills remained elusive. Side and rear shots produced penetrations. Frontal shots at typical ranges did not. German anti-tank doctrine now emphasized 8.8cm flak for hard targets. Field orders directed flak batteries to pre-sight positions covering likely British approach routes. Mobile deployment teams practiced rapid emplacement. Camouflage discipline stressed concealment until targets closed to effective range. The 88mm gun required deliberate positioning and coordination, but its effectiveness against heavy armor justified the effort. General Erwin Rommel commanded Afrika Korps. His experience at Arras in May 1940 informed his approach. The universal 3.7cm solution had been abandoned. Heavy tanks required heavy guns. Rommel's tactical instructions specified combined arms, Panzer III tanks for maneuver and exploitation, 88mm flak for anti-tank ambushes, and aggressive reconnaissance to locate British armor before engagement. 5th Light Division, later redesignated 15th Panzer Division, deployed forward. British 7th Armored Division and support group elements conducted screening operations. Early skirmishes tested German doctrine. Matildas continued to demonstrate frontal immunity to standard anti-tank calibers. But the presence of 88mm guns in forward areas changed engagement dynamics. British intelligence summaries noted an increased 88mm presence. Reports described well-sighted gun positions covering key routes. Tankers received warnings. Bypass suspected flak positions. Call for artillery support. Avoid frontal assaults into prepared defenses. The 50mm armor-piercing round improved side and oblique shot prospects but not consistent frontal kills. Tactical notes from German anti-tank units stressed flanking maneuvers and combined arms. Pin the British tanks with Panzer III fire, maneuver for side shots, or draw them into 88mm kill zones. Afrika Korps field orders from spring 1941 documented the evolution. One example specified 88mm anti-tank ambush positions covering a Wadi approach. Another detailed coordination between panzer reconnaissance elements and flak batteries during a withdrawal. The Matilda problem had forced doctrinal adaptation at the operational level. The presence of Matildas forced German units to reorganize gun lines and task flak assets against ground targets. This affected air defense allocations. Batteries positioned for anti-tank work could not simultaneously provide anti-aircraft coverage. The trade-off was accepted because the alternative, allowing Matildas to overrun positions, was worse. To stop a British infantry tank, the Luftwaffe's primary heavy anti-aircraft gun became the desert's most feared anti-armor weapon. By mid-1941, both sides understood the reality. The Matilda retained frontal immunity to most German anti-tank weapons. But the 88mm gun could kill it. Tactical success required avoiding those guns or suppressing them before closing. Operational success required logistics, air support, and combined arms, not just armor thickness. The Matilda remained formidable, but it was no longer invincible. The balance in North Africa was shifting. Factory ledgers from Vickers, Fowler, and Ruston and Hornsby track castings, gearboxes, and turret rings through production lines. Each Matilda II required extensive machining. The cast armor sections demanded quality control to prevent flaws. The Wilson epicyclic gearbox required precision assembly. Turret rings needed careful fitting to ensure smooth traverse under combat conditions. Theater workshops in Egypt and Libya logged radiator cleanings, track pin replacements, and bogie overhauls after sand ingress. Desert conditions accelerated wear on suspension components. Sand infiltrated every seal and bearing. Cooling systems required frequent maintenance. Engine air filters needed replacement after every few days of operation. Maintenance crews worked under canvas shelters, often within artillery range. They stripped gearboxes, replaced worn parts, and reassembled vehicles for return to units. The Matilda's complexity meant that field repairs took longer than for simpler designs. But the diesel engines proved durable, and the heavy armor meant that many damaged vehicles could be recovered and repaired. Britain expanded Matilda production but could not match the per-month rates of lighter tanks. The design's complexity and armor thickness limited output. By mid-1941, monthly production peaked, but total numbers remained modest compared to cruiser tank production or the output of German Panzer III and IV factories. Meanwhile, the A-12's QF 2-pounder gun lacked a widely issued high-explosive round. The armor-piercing projectile excelled against tanks and hardened targets. But infantry support effects against anti-tank crews in open positions and field works were limited. Tankers requested high-explosive shells for suppression fire. Supplies remained limited due to production priorities. By 1942, newer German tanks carried improved armor. The Panzer III Ausführung J variant mounted 50 mm of frontal plate. The Panzer IV Ausführung F2 introduced the long 7.5 cm KWK 40L43 gun with excellent anti-tank performance. British 2-pounder guns could still penetrate these targets at typical ranges, but the margin of superiority was narrowing. British tank development moved toward the next generation. The infantry tank Mark III Valentine offered better production rates and improved mechanical reliability, though with thinner armor than the Matilda. The infantry tank Mark IV Churchill mounted a heavier gun and thicker armor but faced early mechanical problems. The cruiser tank line evolved toward the Crusader and later the Cromwell. The Matilda II remained in production through mid-1943, but by 1942, its limitations were evident. Slow speed restricted operational flexibility. The 2-pounder gun, though effective in 1940, was being outclassed by German tank guns and armor improvements. The lack of high-explosive ammunition limited infantry support effectiveness. The concept that had defined the Matilda maximum protection, modest speed, had achieved remarkable success in 1940 and 1941. But tank warfare was evolving. Engagements at longer ranges, heavier guns on both sides, and more mobile operations demanded different characteristics. The Matilda's design had been optimized for the breakthrough role in set-piece attacks. That role remained relevant, but broader operational requirements now favored more balanced designs. By late 1942, the Matilda's frontline role in North Africa was diminishing. Newer tanks replaced it in most units, but the legacy of its design remained. It had forced an enemy to redesign his arsenal. It had dominated a theater for 2 years, and it had proven that heavy armor, properly applied, could alter the course of battles and campaigns. The strategic cascade that began at Arras reached full expression in the weapons programs launched in the second half of 1940. German procurement directives documented the decision tree. British heavy tanks required heavy guns. The PaK-38 50mm gun improved performance but remained marginal against 78mm frontal armor. A heavier weapon was necessary. Rheinmetall engineers finalized the PaK-40 design. 7.5 cm L46, long-barreled, high velocity. Firing trials showed excellent penetration against hardened plate representatives of Allied practice. The gun could defeat the Matilda at combat ranges. It could also defeat most other Allied tanks expected through 1943. Production orders accelerated. Initial units reached the field in late 1941. By mid-1942, the PaK-40 was entering service across theaters. Eastern Front, North Africa, Western Europe. The gun that the Matilda had forced into existence became Germany's standard heavy anti-tank weapon for the remainder of the war. The procurement decision carried opportunity costs. Resources allocated to PaK-40 production competed with other programs. The gun required more raw materials, more machining time, and more logistical support than the 3.7-centimeter PaK-36. Germany committed to heavier anti-tank weapons across the force structure because lighter weapons had proven inadequate. One British tank design, deployed in modest numbers, had triggered a multi-year rearmament program affecting thousands of guns and hundreds of thousands of shells. The ripple effects extended beyond hardware. Doctrine changed. Training changed. Tactical employment of anti-tank assets evolved to emphasize heavier calibers and coordinated ambushes. Similar cascades occurred on the Allied side. German responses to the Matilda, particularly the widespread deployment of 88mm flak in the anti-tank role, forced British armor doctrine to emphasize combined arms. Tanks operating without artillery support and infantry screening became vulnerable to prepared defenses. The independent armor thrust, effective against Italian forces in Operation Compass, became problematic against Germans equipped with 88s. British tank development accelerated toward heavier guns and improved armor. The 2-pounder was replaced by the 6-pounder 57mm gun in new designs. Armor thickness increased on cruiser tanks and infantry tanks. Fire control and optics improved. The lessons of Arras and the desert campaigns fed into design specifications for the next generation. Matilda II did not win the war. No single weapons system wins wars. But it altered the trajectory of weapons development on both sides. It forced adversaries to adapt. It validated design choices that prioritized protection. And it demonstrated that armor superiority, even in modest numbers, could produce operational effects far beyond immediate tactical outcomes. The strategic cascade from Arras shaped the anti-tank battle through 1945. German investment in heavier guns created a more lethal battlefield for all Allied armor. British responses influenced the design of American tanks like the M4 Sherman, which entered service with lessons from British combat experience already incorporated. One committee decision in London, June 1936. One tank design optimized for protection over speed. One engagement at Arras, May 1940. And a cascade of consequences that reshaped armored warfare across 2 continents for 5 years. The Matilda II had achieved what few weapon systems achieve. It had forced an entire reevaluation of enemy doctrine and procurement. The slow infantry tank became the catalyst for a strategic arms race in anti-tank weapons that neither side could afford to lose. As frontline tank units in North Africa transitioned to newer designs, the question became what to do with Matilda IIs in inventory. Hundreds remained serviceable. Their armor remained valuable even if their gun and speed had limitations. British engineers and tactical planners developed conversion programs. The Matilda Frog emerged as one solution. A flame-throwing tank. The 2-pounder gun was removed. A flame projector was installed in its place. Fuel tanks for the flame weapon occupied the turret. The hull carried pressurized tanks and pumps. The heavy armor that had made the Matilda effective against anti-tank guns now protected flame tank crews from small arms and shell fragments during close assaults. Conversion manuals documented the modifications. Flame projector specifications, fuel capacity, range estimates, operational procedures. The Matilda Frog entered service with British and Commonwealth units assigned to assault fortified positions where flame weapons provided tactical advantage. Another conversion produced the Matilda Dozer, fitted with engineer equipment for obstacle clearance. The armor protected crews during mine-clearing operations and demolition work under fire. Other variants included command tanks with additional radios and recovery vehicles with winches and towing equipment. In the Southwest Pacific Theater, Australian forces received Matildas for operations against Japanese positions. The slow speed, a liability in open desert warfare, mattered less in jungle terrain where maneuver space was restricted. The armor provided excellent protection against Japanese anti-tank guns, which generally could not penetrate Matilda frontal plate. The 2-pounder gun remained effective against Japanese light tanks and bunkers. Australian units deployed Matildas in New Guinea and Bougainville campaigns. After-action reports noted effectiveness in close terrain and assault operations. The tank's characteristics: heavy armor, low speed, adequate gun for infantry support, suited the tactical conditions in jungle warfare. Japanese forces lacked weapons comparable to German 88mm flak guns. Matilda crews faced less lethal anti-armor threats than their counterparts had faced in North Africa. The British also used Matildas in the training role. Crew training on heavy armor could utilize older vehicles while newer tanks deployed to combat units. Gunnery schools used Matildas for instruction on turret operation, fire control, and armor tactics. Mechanical training units employed them to teach maintenance procedures on diesel engines and epicyclic gearboxes. Second-line service extended the Matilda's operational life well beyond its front-line viability. The vehicles that had faced Rommel's 88s in the desert now served in roles that leveraged their strengths while accepting their limitations. Conversion programs demonstrated the versatility of a well-armored hull, even when the original configuration became obsolete. By 1944, Matilda II production had ended, but existing vehicles remained in service across multiple theaters and roles. Some continued operating into 1945, particularly in the Pacific and in training establishments. The last combat actions involving Matildas likely occurred in the Southwest Pacific in mid-1945, against Japanese positions where heavy armor still provided tactical advantage. The tank that had revolutionized anti-tank warfare in 1940 finished the war in secondary roles, adapted to new missions, training the next generation of tankers, and serving in theaters where its characteristics remained valuable. Not every weapons system achieves that longevity. Many designs become obsolete and are scrapped. The Matilda II adapted and, in adapting, continued to serve. The British Army Armour Development Committee compiled reports on tank performance throughout the war. The Matilda II section documented strengths, weaknesses, and lessons for future design. The technical legacy was clear. Heavy armor works. When properly applied, armor thickness can provide immunity to standard anti-tank weapons. The Matilda's 78mm frontal plate achieved its design goal. It resisted German 3.7cm guns. It resisted Italian 47mm guns. It forced adversaries to deploy heavier weapons and adopt new tactics. But heavy armor requires trade-offs. The Matilda's weight reduced speed and mobility. Cross-country performance suffered. Strategic mobility, the ability to move quickly between sectors, was limited. Operational tempo in fluid battles favored faster tanks. The protection that made the Matilda dominant in set-piece attacks became a liability in mobile warfare. Gun armament must evolve with armor threats. The 2-pounder gun was excellent in 1939 and 1940. By 1942, enemy tank armor had improved. German Panzer III and IV variants carried heavier guns and thicker plate. The 2-pounder remained adequate but no longer superior. Future designs would require growth potential for heavier guns. Logistics and maintenance matter as much as combat performance. The Matilda's complexity increased maintenance burden. Desert operations exposed vulnerabilities in cooling and filtration systems. Every design decision has second-order effects on supply chains and repair capacity. Simple, reliable designs can outnumber complex, capable designs through superior production rates and lower maintenance requirements. Infantry support tanks require high-explosive ammunition. The lack of widespread HE rounds for the 2-pounder limited effectiveness against soft targets. Anti-tank crews, machine gun nests, and field fortifications required suppression fire that armor-piercing rounds could not provide. Future infantry support designs emphasized dual-purpose ammunition. The committee's conclusions influenced post-war tank development. British designs moved toward universal tanks, combining armor, mobility, and firepower in balanced packages. The split between infantry tanks and cruiser tanks was gradually abandoned. Lessons from Matilda service informed specifications for post-war vehicles like the Centurion, which entered service in 1945 and served for decades. The Matilda II also influenced Allied tank design through shared experience. American tank development incorporated British combat reports. The M4 Sherman reflected lessons about reliability, production efficiency, and combined arms doctrine. Soviet heavy tank programs pursued armor protection with intensity similar to the British infantry tank concept, producing vehicles like the KV series with extremely thick armor. German tank development responded directly to the Matilda threat. The PaK 47.5 cm gun became standard. The Tiger I heavy tank, with 80 to 100 mm of frontal armor, represented Germany's answer to the armor protection philosophy. The Panther tank combined armor, mobility, and firepower in a design that learned from encounters with heavy Allied and Soviet tanks. The tactical lessons extended beyond hardware. Combined arms doctrine evolved. Tanks operating with infantry, artillery, and air support proved more effective than independent armor thrusts. The Matilda's vulnerabilities to prepared defenses reinforced the importance of reconnaissance, suppression fire, and maneuver. One tank design, one successful campaign, and a legacy that shaped armor development for a generation. The Matilda II forced adversaries to adapt, validated protection-focused design, and demonstrated both the potential and the limits of heavy armor. Future tanks would balance those lessons into new configurations, but the fundamental questions, how much armor, how much speed, how much firepower, remained the same questions that designers had confronted in 1936. Most Matilda IIs ended their service life in scrapyards. Steel was valuable in post-war reconstruction. Thousands of tanks of all types were cut up for scrap metal. The Matilda's thick armor made it a particularly attractive source of raw material. Cutting torches reduced hulls to manageable sections. The armor plate became steel stock for civilian industry. Some vehicles survived. Museum acquisitions preserved examples for historical study and public display. The Tank Museum at Bovington, England, acquired several Matildas representing different production variants and modifications. Each vehicle carried its own history, inscribed in serial numbers and unit markings. One example, serial number T6891, served with 4th Royal Tank Regiment in France and North Africa. Records trace its deployment from initial issue in early 1940, through the Arras counterattack, evacuation from Dunkirk, refitting, and redeployment to Egypt. Combat damage visible on the hull includes impact marks from 3.7 cm rounds and scars from near misses by larger shells. None penetrated the frontal armor. Restoration work at Bovington documented the vehicle's construction. Cast armor sections showed the manufacturing techniques of the era. The twin AEC diesel engines remained largely intact, though non-operational. The Wilson epicyclic gearbox displayed the mechanical complexity that had made field maintenance challenging. The turret traverse mechanism, 2-pounder gun mount, and fire control equipment provided insight into the crew's working conditions. Other museums across Commonwealth nations preserved Matilda IIs with local service history. Australia's Australian War Memorial in Canberra displays a Matilda that served in the Southwest Pacific. Its modifications for tropical conditions and jungle warfare illustrate adaptation of European equipment to different theaters. Canada, New Zealand, and South Africa also preserved examples with their own operational histories. Private collectors and military vehicle preservation groups restored additional Matildas to running condition. These restored vehicles participate in historical demonstrations and commemorative events. The sound of twin diesels and the sight of 78 mm armor moving across fields provide a tangible connection to the experiences of crews who fought in them. Preserved Matildas serve as teaching tools. Visitors can observe the thickness of armor that resisted German anti-tank guns. They can see the cramped interior spaces where crews operated under combat conditions. They can examine the mechanical systems that require constant maintenance in harsh environments. Each preserved vehicle represents thousands that served and were scrapped, a physical reminder of industrial-scale warfare. The survivors stand as monuments to the crews who operated them. Tankers who faced 88 mm guns at Arras. Crews who breached Italian fortifications at Bardia. Soldiers who adapted flame-throwing conversions in Pacific jungles. Each preserved Matilda carries those stories forward into present memory. Museums continue restoration and preservation work. The armor plate receives conservation treatment to prevent further corrosion. Mechanical components are documented and, where possible, kept in working order. Serial numbers and unit markings are researched to identify specific operational histories. The work ensures that future generations can study the vehicle that forced Germany to rearm and dominated North Africa for 2 years. 85 years after its design conception, what can be said of the infantry tank Mark II, the Matilda? By conventional metrics, it was a limited success. Production numbers remained modest, fewer than 3,000 units total. Frontline service lasted only a few years before more capable designs replaced it. It suffered from slow speed, limited gun growth potential, and high production cost. These are significant limitations. But success in weapons design is not measured only by production numbers or service life. Success is measured by impact on enemy doctrine, influence on subsequent designs, and effectiveness in the roles for which the weapon was intended. By these metrics, the Matilda II achieved remarkable success. It forced Germany to accelerate development of the PaK 47.5 cm gun and deploy 88 mm flak guns in anti-tank roles. That doctrinal shift affected German tactics and resource allocation for the remainder of the war. The strategic cascade from Arras shaped the anti-tank battle across all theaters. It dominated North Africa from December 1940 through mid-1941, enabling Operation Compass and the destruction of the Italian 10th Army. That campaign reset the Mediterranean balance and delayed Axis control of the region by years. The operational effects exceeded the immediate tactical outcomes of individual battles. It validated armor protection design philosophy and influenced post-war tank development. The questions it forced designers to confront, how to balance protection, firepower, and mobility, remained central to armored vehicle design for decades. The Centurion, the M60, and subsequent generations incorporated lessons from Matilda service. It demonstrated that modest numbers of well-designed vehicles can produce effects disproportionate to their numerical strength. 58 Matilda IIs at Arras triggered a German rearmament program. 120 Matildas in Operation Compass enabled the capture of 130,000 prisoners. Quality, properly applied, can overcome quantity. The crews who operated Matildas faced the same dangers all tankers face. Mechanical breakdowns in the desert. 88 mm guns at prepared positions. Mines and anti-tank obstacles. But the armor that protected them worked. Rounds bounced off. Crews survived hits that would have killed them in lighter vehicles. That protection saved lives. In the end, the Matilda II was a product of its time. It reflected British armor doctrine in the late 1930s. It embodied the infantry tank concept, maximum protection for breakthrough operations. It performed that role effectively when conditions suited its characteristics. When conditions changed, it adapted to new roles or gave way to more capable designs. Not every weapon system achieves that combination of tactical success, operational impact, and strategic influence. Many designs fail to meet expectations. Many perform adequately without distinction. A few alter the course of battles and force adversaries to rebuild their arsenals. The Matilda II was one of those few. The tank that was too slow forced the fastest army in Europe to stop and re-equip. That is success. That is the measure of the infantry tank Mark II. The Matilda. What is your perspective on this part of history? Share your thoughts in the comments, because every memory and reflection helps keep the past alive.